Good day, everyone. This day I am going to solve problems involving center of gravity, parallel axis theorem, composite area, product of inertia, and mass moment of inertia. Given mass 1 is equals to 23 kilograms, mass 2 is equals to 6 kilogram, and mass 3 is equals to 20 kilogram. We can now solve for the centroid or center of the gravity using the formula m1 times x1 plus m2 times x2 plus m3 times x3 all over masses that is summed up. Now we have 23 kilogram multiplied by 1 meter time plus 6 kilogram times 3 meter plus 20 kilograms times 4 meter over 23 kilogram plus 6 kilogram plus 20 kilogram. We have 121 kilogram meter over 49 kilogram. Then kilogram will be cancelled out, and using the calculator we have the answer. Now we have the final answer equals to 2.47 meter. Now for the problem number 2, we have the problem involving parallel axis theorem. Parallel axis theorem. We have the mass of the solid sphere, which is equal to 7 kilogram and has a radius 5 meter. Then we have the formula. Inertia is equals to inertia of the column of plus mr squared, which is equal to 2 over 5 mr squared plus mr squared. Now we have 2 over 5 times 7 kilogram times 0.5 meter squared plus 7 kilogram times 0.5 meter squared. We have 0. Kilogram meter squared plus 1.75 kilogram meter squared, which is equal to 2.45 kilogram meter squared. This problem involves mass moment of inertia. Given mass of each segment is equals to 6 kilogram meter times 0.2 meter, which is equals to 1.2 kilograms. To solve for the mass moment inertia, we have Ig is equals to 1 over 12 times mass of inertia times length squared. We have this formula to solve for the mass moment of inertia. Then 1 over 12 times 1.2 times 0.2 squared plus 1.2 multiplied by 0.1 squared plus 1 over 12 times 1.2 times 0.2 squared plus 1.2 times 0.2 squared, which is equals to 0.64 kilogram meter squared. Before we solve this problem, we need first to go back for this simple formula, which is helpful for us to find for the solve for the composite area. Now we can solve for the inertia of the composite area, which Ix is equals to 80 times cube of 60 all over 12 minus 40 times cube of 30 over 36 minus pi over 10 minus 4 over 9 pi times 30 raised to the 4th power plus 80 times 60 times 30 cube minus 40 times 30 all over 2 times 30 over 3 squared minus pi multiplied by squared of 30 over 4, 6 times 60 minus 4 times 30 over 3 pi squared. Now we have Ix is equals to 385,8402.5633 millimeter raised to the power of 4. Now to solve for Iy, we have 60 times 8 cube of 80 or all over 12 minus 30 times cube of 40 over 36 minus pi over 10 minus 4 over 9 pi times 30 raised to the power of 4 plus 80 times 60 times square of 40 minus 40 times 30 all over 2 times 40 plus 2 times 40 over 3 squared minus pi 30 squared over 4 times 4 times 30 over 3 pi squared. Now we have Iy equals to 7404862.596 millimeter raised to the power of 4. For the last problem, this involves the product area. Ix is equals to 1/3 times b multiplied by cube of b, which is equals to 1/3 b raised to 4. Same with Iy. Now we have the inertia along x and y axis equals 0 plus b all over 2 times b over 2 times b squared, with theta is equals to 30 degrees, using the equation of moment of inertia about any inclined axis. Now we have inertia along x is equals to Ix plus Iy over 2 plus Ix minus Iy over 2 is equal times cosine 20 minus Ixy sine 20. Now for inertia along y equals to Ix plus Iy over 2 minus Ix minus Iy over 2 cos 20 plus Ixy sine 20. For the inertia along x and y axis, we have Ixy minus Iy over 2 sine theta plus Ixy cos 20. We get inertia along x is equals to b raised to 4 over 3 plus 0 minus 1/4 of b raised to 4 sine 60, and the final answer is 0.117 b raised to 4. For the Iy, b raised to 4 over 3 plus 0 plus 1/4 plus times b raised to 4 times sine 60 is equals to 1/3 plus cubic of 3 all over 8 b4 is equals to 0.55 b raised to 4. Lastly, for the inertia along x and y axis is equals to 0 times 0 plus 1/4 times b raised to 4 times 1/2 is equals to 1/8 x b raised to 4, which is equals to 0.125 b raised to 4.